Saudi Arabia that kidnap puppy wolves, raise them, and sort of domesticate them. I never heard of anything like that. Except I think someone just gave a presentation and showed film.
See, what's it working? I asked if I wanted to go, and I was like, no, so I just had to go.
Okay. Now, we're going to go over, as you've heard me say before, we can make a deal. No, we can't. No, we can't do that. However, if it's free, no. Now,
what if we find about don't follow?
that's right. Now, if you remember, they scramble these things. So do not think that the order I'm going in is in any way going to be the order you're going to see. Got it?
Got it.
Do not even think that the answers are going to get scrambled too. So I can't help you, well, I wouldn't be allowed to help you there anyway, but just know that. So they're doing everything to make it difficult for you.
Just a little proof-based question. Are Dr. Hahn's questions going to be on this line?
You know, some of them aren't mine. So I'm assuming they must be his.
Probably is.
I was going over this and I said, did I write that? I didn't. 50.
Okay.
It's 50 questions, 2 points a question. And as I try, I've given up. I used to have, extra credit, but you can't do it because somehow the computer can't deal with it. Help, really, but that's what they say. So I can't have any extra credits anymore. It's too bad. Okay, are we ready? Oh, God. Is it the weekend yet, please? All right. Now, first one. Well, see that? This has got to be Han's question. This isn't mine. I would never ask this. Now, of all this, in the skull, see, I have to paraphrase this. In the skull, what region of the skull is closest to its adult form in the newborn? I mean, you've got the viscerocranium, right? The facial, you got the calvarium, right? The neurocranium. That's all I'm going to say. So, which one's closer to the adult? That's not too hard, really. Think it out. All right, do you remember, oh God, do you? I know you do. You've got the neural plate, and the neural plate starts to fold in on itself and makes the neural groove, la-da-da-da-da-da-da. And then it finally forms the neural tube. There is a name for that process. Do you remember what that name is? Oh, it's just another thing. I'm going to just tell you. I'm doing this to help you guys. In my questions, I always have a ludicrous answer. So that helps you. I mean, if there's something really stupid in there, please do not check it. I mean, okay. I mean, go through and just think about it. So when you got the neural tube and it folds in on itself, there's a process that's called that, and it's called a implantation. I don't think so. I mean, really. Okay, you can't miss that. Somatification. How did I come up with that? That must have been after a couple of years or so. Somatification, that's not even a word. Okay. The third, the ventricles of the brain The third and the fourth ventricle are connected by that little tiny tube. And if the tube gets blocked, you end up with hydrocephaly, right? What's the name of the tube? Okay, the cribriform plate. You know, that little thing with all those holes in it. And in humans, it's horizontal. What nerve goes through the cribriform plate? If you put the optic nerve, I'll kill you. So just know that. Okay. The temporalis and the master muscles are innervated by what? Remember what pharyngeal arch it is? What nerve goes to that pharyngeal arch? Remember that nerve has to go to the muscles that come from the arch, right? Oh gosh, look at this. If you block that little tube between the third and fourth ventricle, what happens? I already told you. How many ventricles in a human brain? Do we have 10? I don't think so. Do we have 1? No. Somewhere between that. The pituitary gland resides in what fossa? You know that. That's the Turkish saddle, right? Yeah. I'm too good to you people. I'm too good to you. Okay, now remember.
That's what I told her to do.
You've got a pituitary gland and you've got one piece of it coming down from the top. Another piece comes up from the bottom. And it forms the anterior and the posterior lobe of the pituitary, right? The piece from the top comes in from the diencephalon. Is that what, let me see. No, that's, you've got 2 lobes. What, know the 2 lobes of the pituitary, where they come from. That's easy. Why? You know, I'm too nice. I should be meaner. I really should. The diverticulum that comes from the bottom, it's also called Rathke's pouch, that forms, where does it come from? It's all ectoderm, remember that? And what lines the inside of your mouth, stomadeum, is ectoderm. A piece of it goes up. The 5, okay, now I hate to do this to you, but you gotta know this. You'll forget it. I mean, in your practice, it will never help you a bit. But it doesn't matter, you gotta know it. You got exams, you gotta take. Now, know when the brain starts, you've got the forebrain, the midbrain, and the hindbrain, right? The procephalon, the mesencephalon, and the hindbrain. They then know the divergence. In the forebrain, you end up with the diencephalon and the telencephalon. Midbrain, don't worry about it, it stays the same. Posterior brain, what do you end up with? The mesencephalon and the myelencephalon. It's a pain, but just know that. Oh, okay, if you take the brain stem, or the spinal cord, I don't care, but since we're talking about brains, and you cut through it, you've got that little butterfly in there, right? And one of the plates is on the dorsal surface, it's the alar plate, and on the bottom, it's the basal plate. One of those is efferent, one of those is afferent. Efferent meaning it's going out, afferent means it's coming in. Know which one is which. Oh, God. So we probably said this, just know your basic portions of the brain as it's developing. That's all. You know, there's in my slide, it shows you the 3, and then the forebrain goes into 2, and the hindbrain goes into 2, and the midbrain stays the same. Just know that little pathway. All right, and know about okay, neural tissue in your body is always surrounded in the central nervous system. In the central nervous system, it's surrounded by membranes. And the outside membrane is the tough mother. That's what it means. Dura mater, right? And then you've got the arachnoid and you got the pia, right? And then you've got subarachnoid space, and that's where the cerebrospinal fluid goes up and down, right? Okay, got it. This is, okay, now I know we've talked about this, but I really didn't, I presume, we talked about it in the other class, but you've got 2 basic types of bone as they grow. One is endochondral, which has a cartilaginous model, and then an onlога, and then the other one is intramembranous, right? Where you do not have a cartilaginous model. And the neural cranium, is all intramembranous, except for the occipital, and a couple pieces on around the face, but not many. So it's just know the 2 basic types of bone: endochondral and intramembranous. Which I'm not going to talk about it. Yeah, well, I will just. For those, this is not on the test, but it really is the same situation if you think about it. Because you're laying down bone through the periosteum to make the bone bigger. It's really the same thing. But when they first start out, they're different. Know your facial prominences. That's an important one. You got to know those. There's 5 of them, right? And I know if you divide the lateral and medial nasal, you can get 7, but just know the 5. You got the facial prominences. What innervates the muscles of the tongue? You gotta learn. Remember, the tongue comes from occipital somites, migrates into the face, and it drags the nerve with it, so it has its own nerve supply. It's not trigeminal. Trigeminal is the sensory on the surface of the tongue. It's not that. I'm asking for what efferent nerve goes to the muscles of the tongue. It even has the word tongue in it. Glossal. What happens if your thyroid gland doesn't descend the way it's supposed to do and you end up with a cyst? Know that idea, the concept. Because the thyroid gland goes down that little, what's the name of that sulcus? You got sulcus terminalis on your tongue, and then you've got that little hole, foramen cecum in your tongue, and the thyroid gland goes down there. And if it gets stopped before it gets to your neck, it can cause all sorts of issues. All right, now you remember, God, I hate to do this to you, but I hate to do it to myself too. Okay, you've got the first pharyngeal arch, and then you've got the second pharyngeal arch. Okay. It's important stuff, but it even kills me to go over it again and again and again. Now the second arch overgrows the third and the fourth. You remember that? It grows over them, and it closes, and later on, by the end of the first trimester, you can't even see the third and the fourth arch anymore. The grooves, you can't even see them because they're grown over by the second. If the second does not grow over and close those grooves on the external side, what happens? And you'll see those, because those aren't very, those are pretty common. And again, in that question, if you check Harry Pinney, I'll kill you. Come on, man. And it's just, what else did I say? Pes planus. Pes planus is flat feet. So do not check that box. All right, again, the first pharyngeal groove, the cleft, external, gives rise to what? Oh, did I just give a hint? Perhaps I did. Okay. The foramen magnum. In humans, the foramen magnum, that's a big hole. That's what foramen magnum means, is a big hole in the bottom of your skull. And that's where your spinal cord, right, goes down. And in humans, which direction has it moved? Well, it's mid-sagittal, right? It's got to be mid-sagittal. I can't think of anything where it's not. It's mid-sagittal, so it's either got to go forward or backward. Which way in humans, embryologically as well as evolutionary, does it move? Does it migrate? Come on, you're balancing your head, right? Now, this must... Okay, if you're going, I will just tell you this. Did Hans talk about the different facial planes? He must have. Talk about facial growth? Yeah. The mid-facial plane? Did he talk about that? And it's not something that flies. Not that kind of a plane. It has, okay, if you take a line through the front of your brain, the very anterior-most extension of your brain, and you come to procyon. You know what procyon is? Okay, procyon is that space between your incisors, right here. And you draw a line through that. What is the name of that line? Well, I'll tell you. I guess I shouldn't, should I? You're supposed to go study. Well, might be called midterm point. I don't know, I'm too nuts. All right, you got ear bones, right? You have ossicles. Well, let me finish before I say this. You have ear ossicles, which are the only bones in your body that when you are born, the day you are born, those are the same ear ossicles that you will die with. They do not change with age. You're born with them. Kind of cool. How does selection work on those? But anyway, it doesn't matter. The first arch gives rise to two of them, and the second arch gives rise to a third, which if you remember my story, which I know you probably don't, it's such a good story, that particular ossicle came from the reptilian jaw joint. Because the reptilians have such a complex jaw joint. Because they didn't have a massive muscle, but I'm getting because of that. I'm not asking you that stuff. But so in the second arch, you get which of the ear ossicles? Okay. On the third, On the third arch, there's a muscle that develops from the third arch. In fact, I'll give you a hint. There's a styloid process that comes off of your sphenoid. You know that little styloid process comes down? There is a muscle that attaches to that. Know that. Oh, this is a good one. Again, you already know this, but in bone, what happens is, okay, you've got the osteoblasts and the osteoclasts. Clast takes away, blast builds the bone. Which is an interesting. Do you know, I know, but I have to do this, otherwise I'll go mad. Do you know that serotonin, which is the happy drug, right? It's a hormone. In humans, we have more serotonin receptors than any other primate, which is, the reason is to probably get rid of male aggression. So we're not killing each other all the time, kill each other enough. Anyway, the serotonin also inhibits osteoblasts. You know how they found this out? Because they gave people that are depressed serotonin, and it turns out it gives them osteoporosis. Who knew? But it does. That's probably why the human skeleton 10,000 years ago fell apart. The human skeleton is the weakest skeleton of all mammals for our body size. And it's probably because of serotonin. This has nothing to do with your test. But I'm working on that project right now, and I'm fascinated. Anyway, in bone, what happens is you end up with the osteocytes. The osteocyte, the bone cell, gets locked in its matrix, right? It gets locked in its matrix, so it can't expand. Because it's cemented inside of the hard matrix, the mineral. Therefore, for a bone to grow, how can it grow? It can't grow from inside anymore. In a soft tissue, it can grow from inside. Not in bone, because you're locked in there. And that's why you have diversion canals, so you can get the blood supply into the osteocyte so it doesn't die. But what we're talking about is when the bone grows, how does it grow? What type of growth is that called? Is it called, Jesus, I can't even believe it. Dynapsid encroachment? No, it is not dynapsid encroachment. I don't even know what dynapsid encroachment is. I made it up. It's not that. Is it Mullerian reduction? What is that? No. So you can't miss this. Okay, your tongue is broken into two parts. The anterior part and the posterior part. And it's the sulcus terminalis that determines which is which. The anterior part is the oral part. I don't know, you know that. The posterior part of your tongue is the pharyngeal part, right? Because it's back in your pharynx. And just know that. Oh, and no, yeah, just know that. The central nervous system, which is the brain and the spinal cord, the central nervous system is what tissue? What does it derive from? God, if you put endoderm, I will come and get you. It is not endoderm and it is not mesoderm. What could it be? I don't know. All right, the cerebellum, that's the back here. What's the cerebellum good for? Well, for years we thought it was all muscular control and balance, but Turns out it does more than that, but it doesn't, that's not what I'm asking. The cerebellum derives from what part of the fetal brain? That's pretty easy, given where it is. Remember that the forebrain gives rise to two different parts, the diencephalon and the telencephalon. Yeah, and those then give rise to what in the brain? In the adult, you don't call them the diencephalon, it's telencephalon anymore. If you look inside of a skull that's been sectioned, you take the top off of the skull, and you look into it, you've got those fossa. You've got the anterior fossa, the middle fossa, and the posterior. Well, the posterior is where the cerebellum sits, right? What sits in the other guy, in the other fossa? Just know what sits in that place. Oh God, you know, I know why they do this. Meckel's cartilage. I know I've told you this 1,000 times. And the reason that they do this is that they want to make sure that you know that the mandible is intramembranous, right? So you can't say Meckel's cartilage forms the mandible, because if you did say that, it would be endochondral, now wouldn't it? Now we're parsing here and we're splitting hairs. But given that's the case, Meckel's cartilage does not give rise to the mandible directly. God, why? I know this is why they're doing it. Meckel's cartilage does give rise directly to a particular bone. Two bones. What bones are those? You know, Meckel's cartilage goes like this, and it's the most dorsal part of the Meckel's cartilage, and it gives rise to a couple of bones. Again, do you remember in a growing skull, in a fetal skull, in order to get it through the birth canal, you've got to have those cartilaginous pads in there that allow the plates to move around. And that's why when babies are born, they always have cone heads. They are. Babies don't look good when they first come out. That's why they give them those little hats. They do. That's why they put these little hats on babies, because they don't want the mother going, oh my God, a cone head. I mean, it's kind of a traumatic thing, right? So anyway, it goes away in 24 hours, so don't worry about it. But if you tell the mother that right after she's gone through labor, she's got a little upset anyway. She's worried about a cone-headed baby. Well, the reason that you have those cartilaginous pads called fontanelles, right? Well, the fontanelles allow it to move around to get through the birth canal, because it's really difficult. Our brains got too big for our pelvis. Now, there's sutures that obliterate later in life. When I say later, usually about 5 or 6 years old. One of which is the one right here, between the frontal. The frontal bone is originally 2 pieces. And you've got a suture right here. What's the name of that suture? Okay, you know where the pituitary sits. And we did talk about this. It sits in the sphenoid, immediately anterior to the pituitary, the cell tertica. Immediately anterior to it, there's a cross, a chiasm. of nerves. What nerve is that? You know, come on, we talked about if you do get a tumor there, it affects those nerves. Yeah. Oh, why? I don't know, sometimes. Okay, the neural plate. You know, you get the primitive groove. I don't care about that. The neural plate goes like this. And when it goes like that, it forms, it's not a plate anymore, it forms something else. What is that called? And what does it give rise to if you, that little hole that's in there? Some of these are just too easy. But that's okay. Did he talk about the Frankfurt horizontal? He did? Do you know how you define the Frankfurt horizontal? I mean, there's a point here called orbitality, and there's a point here called chorion, right? Chorion and orbitality, and if you draw a line through that, and you make it horizontal, that line is the Frankfurt horizontal. Does that make sense? Did you know that?
I thought it was
It's chorion and orbitality. And that's, you have no idea how hard, they figured this out in, I don't know, 1880 or something. Because they had a terrible time trying to, how do you orient the skull? If you don't orient it, then you can't take the measurements and the angular measurements and all that stuff. So they had to come up with Frankfurt horizontal answer. So yes, no, it's chorion and orbitality. And you're all going to get A's. And remember, some of you get an extra point anyway. Yeah, for those of you who weren't here that day, too bad. Any questions? How can you have questions after what?
Are there any more questions that we didn't discuss that perhaps we should be discussing?
No, I pretty much hit everything. Pretty much. I mean, anything that's in here, when you take exams like this amazes me. There are people, and I know one. He actually, his name's Peter Scholes, and Peter was an orthopedic surgeon here. And he left to go work in Philadelphia at the, I don't know, the American Medical Association, blah, 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 blah. And he's the guy that figures out the MCATs, the tests and stuff. If you gave him this, I will guarantee you he can hit 90% on it, even if he doesn't know what it's talking about. Because there are ways to do it. He knows how to read a test and how to figure out on these kind of tests how to do it. Now, that's why, the reason I'm telling you this is if you hit a question that you're not sure about, take a breath and read all the answers. Because there's going to be some stupid answers in here. And you can immediately say, well, it's not flat feet, right? Guaranteed it's not flat feet. And it's not some word you've never ever heard of. So you can, if you don't panic, is I guess what I'm saying. So you all get A's. Have fun studying. And I'm going to go read about baboons and wolves.